Hello, and welcome to another lesson from Level Up Mathematics. In today's lesson, we are going to be exploring how to find specific function values from equations, tables, and graphs. Function notation will play a big role in this course, and it is important that you become comfortable with functions expressed in function notation. So before we begin, let's look at an equation that's expressed in function notation and label the different parts of our equation. So in this problem, we have h of t is equal to 2t plus 3. The h represents the function name. The t represents our input variable. And the 2t plus 3 represents our function rule. So in this function, they want you to take each input value, multiply it by 2, and then add 3. So let's look at a quick example of this. If h of t is equal to 2t plus 3, find h of 10. So they want you to take the 10 and multiply it by 2 and then add 3. So we'll simply plug a 10 in for the t and evaluate that. So 2 times 10 is 20. 20 plus 3 would give us 23. Now, in this course, sometimes you'll be given expressions to plug in for your input variable. So we'll work that the same way. We'll have 2, replace the t with parentheses, then plug in whatever they're giving you. In this problem, t minus 4 is our input, and then we'll simplify that. So using the distributive property, 2t minus 8 plus 3, and then combine like terms. So 2t minus 5. So you're not always getting just a number. Sometimes you're getting an algebraic expression when you evaluate functions. In our first example, it says if f of x is equal to x minus 4 squared plus 2, and g of x equals 2 times 3 to the x power, find each of the following. So in problem A, they want us to find f of negative 2. Now, it's important that we plug our negative 2 into the proper function. So because our function name is f, we want to use our f of x function. So I'm going to take my function and plug in a negative 2 for the x. So we'd have negative 2 minus 4 squared plus 2. So this would give us negative 6 squared plus 2. Negative 6 times negative 6 is 36, and 36 plus 2 would give us 38. Now in problem B, they're asking us to evaluate g of 2. So because our function name is g, we want to be sure and plug it into the g of x function. So I'm going to evaluate this 2 times 3 to the 2 power. Now be sure to use your order of operations here. We want to do 3 squared first, which is 9, and then 9 times 2 would give us 18. Problem C, f of 0. So 0 minus 4 squared plus 2 would give us negative 4 squared plus 2. So negative 4 times negative 4 is 16. 16 plus 2 is 18. Now, in problem D, they're asking us to add f of negative 2 and g of 2. Now, this does not equal negative 2 plus 2. We need to find each of these values and then add them together. Luckily, we've already found f of negative 2 in example A. So we know that f of negative 2 was 38. We also have already found g of 2. It was 18. So it's really asking us to add 38 plus 18. So that would give us 56. In problem E, we want to take g of 2, which was 18, and subtract f of 0, which was also 18. So g of 2 minus f of 2 is 0. In problem F, they want us to evaluate 3 times f of negative 1. So the first thing we're going to have to do is find f of negative 1. So to find f of negative 1, I'll plug it into f of x. Negative 1 minus 4 squared plus 2. That would give me negative 5 squared plus 2. Now negative 5 times negative 5 is 25, and 25 plus 2 is 27. So we found f of negative 1, but the question asks us for 3 times f of negative 1. So 3 times 27 would be 60 plus 21, or 81. In example 2, they're going to give us a table of values. So in example 1, we were evaluating functions when they gave us the equation for the function. In example 2, we don't have an equation. All we have is a table of values. Now, to make this a little easier, I'm going to highlight f of x here in pink, and g of x I'll highlight in green. So I'm going to highlight when they're asking for g in green and when they're asking for f in pink. This will help us keep it straight. So in example A, they want us to evaluate f of 3. So when x is 3, what is the value of f of x? And you can clearly see that it is 4. Now they want us to evaluate g of 3. So when x is 3, g of x is equal to 1. Problem C. What value of x solves the equation g of x is equal to 3? So here, they're not giving us the input value, they're giving us the output is 3. So I want to look at the g of x column, find an output of 3, and ask myself, what x value does that correspond to? And it corresponds to x equals positive 4. Problem D. What value of x solves the equation f of x equals negative 3? Now, if I look at the f of x column and I'm looking at the outputs, notice I have a negative 3 there, and I have an output of negative 3 there. So there's 2 different x values that will give us an output of negative 3. And they are x equals 2 and x equals 4. In example 3, we're given a graph. So far, we've looked at evaluating functions given an equation, how to evaluate functions given a table, and in this problem, we're going to look at how to evaluate a function when we're given the graph. So in problem A, they're wanting us to find f of 5. So this is an x value. So this is saying when you put 5 into this function, what do you get out? So here is our input axis. So we're looking along the x-axis. So 1, 2, 3, 4, 5, and then 1, 2, 3. So we get out a 3. So f of negative 1, we would go to negative 1 and count down. 1, 2, 3. And that would be negative 3. F of positive 1, so go to the right one. And that would correspond to an output value of negative 1. f of negative 3. 1, 2, negative 3, and count down. 1, 2, 3, 4, 5. That would give us an output of negative 5. In problem E, it asks us to evaluate f of 0. So f of 0 would be right here. So f of 0 in this problem would be negative 2. Now, when our input value is 0, that means our output has to fall on the y-axis. So f of 0, no matter what the function is, will always be the y-intercept. Now, our next question is a little bit different. It says, what values of x solve the equation f of x equals 0? Notice that 0 is not our input this time. 0 is our output. So when does y equal 0? Well, y is going to, I'm going to circle these in blue. Y is going to equal 0 here and here. So there's two places that the y value is 0. This is negative 5, 0, and this is 2, 0. So what values of x correspond, or excuse me, what values of x solve the equation f of x equals 0? That would be x equals negative 5 and x equals positive 2. F of x equals 0. Whenever your output is 0, will always be the x-intercepts. Sometimes you'll only have one, but sometimes you'll have more than one x-intercept. So you might have more than one answer on problems of this type. In example 4, it says some values for the linear function f are listed below. Represent this function as a table of values. So we have f of 0 is equal to negative 2, f of 2 is equal to 4, and f of 6 is equal to 16. So what this is saying is that if you put 0 into the function, you're going to get out a negative 2. If you put in a 2 to this function, you're going to get out a positive 4. And if you put in a 6, you're going to get out a 16. So that's how we can represent points that are represented in function notation, how we can represent it as a table. Now, the next thing they want us to do is write a rule to describe how f of x can be obtained from x. In other words, what are they doing to each x to get each y value? Now, there's a clue in this problem because it told us that the function was a linear function. And when we write a rule for a linear function, it's always y equals your initial value, or your y-intercept, plus your rate of change. Now, you learned that in a previous course, but I'm sure it's been a while since you've seen it. So just as a review, a linear function, our equation can always be set up as your initial value plus the rate of change. So in this problem, our initial value, or our y-intercept, is negative 2. Now let's get our rate of change. So from our first coordinate to our second coordinate, we're going up 6. And on the x's, we're going up 2. From our second to our third, we're going up 12. And we're going on the x's, we're going up 4. So if I find those ratios, 6 divided by 2 is 3. And 12 divided by 4 is 3. So we know our rate of change is 3. So our rest of our equation be y equals negative 2 plus 3x. So there's our function rule. But you know what? I should probably write this in function notation. So let me write it as f of x equals negative 2 plus 3x. It's the same thing. Okay. So in problem B, they want us to find the value of 3. So this is saying your input value is 3. So we would have negative 2 plus 3 times 3. So order of operations, 3 times 3 is 9, and 9 plus negative 2 would give me positive 7. Problem C, what value of x will solve the equation f of x is equal to negative 8? Now this time our output value is negative 8. We don't know the input value. That's what we're trying to find. So I'm going to take my function and put negative 8 for the output, and then write down our rule, negative 2 plus 3x. And then we'll just solve that for x. So add your 2, so that would give us negative 6 is equal to 3x, and then divide by 3. So x is going to equal negative 2. So when you're doing these problems, just be careful to see is what you're working with an input value or an output value. All right, in our last example, we're giving a graph that has two functions on it. And this is very common in advanced math courses. You might have two functions, and that's the reason for function notation, is we want to give them each a name. So here we have function f, which is a line, and function g, which is a parabola. And they want us to use the graph of these two functions to answer the questions. So on the first one, f of negative 3. So we want to be sure to look at the line. So on this line, if our input value is negative 3, so go to the left, 3, 1, 2, 3, 1, 2, and then up, it has an output value of positive 3. For g of negative 2, go left 2, it has an output value of 1. Right? Problem C, what values of x solve the equation g of x equals negative 1? So our output is negative 1. So I'm going to draw a line here at negative 1. And you can see there's two places that g of x would equal negative 1. Here and here. And what they're asking for is, what are those two x values? So 1, 2, 3, negative 3. And x equals negative 1. All right, problem D. What value of x solves the equation f of x equals 0? Now, I don't know if you remember, but we said f of x, when f of x is equal to 0, that will always represent the x-intercept of that function. So find function f, then we're going to find its x-intercept. Here's where f of x would equal 0. What value of x is that? So 1, 2, 3. So x is equal to 3. And that concludes today's lesson on function notation. If there's anything that's confusing to you, feel free to go back, pause the video, and rewatch it.